Welcome to episode 5 of It's About Data, the podcast about data, AI, analytics, and whatever. It's hosted by Matt Housley of Half Pipe Systems and Tony Baer of DB Insight. And today our special guest is Vin Vashishta. He's a noted AI educator and author. And we're going to talk to him about his idea that when it comes to agents, small is beautiful. Now, what do we mean by that? Take it away, Matt.
All right, Vin, welcome to It's About Data. You're one of our first couple of guests and guinea pigs. And one topic that's on everyone's mind right now is AI agents. Tony, that was kind of a big topic recently at Google Cloud Next. And of course, Vin, you wrote a LinkedIn post about this that got a lot of attention, including ours. Tony, maybe you can say a bit about what you heard at Google Cloud Next.
Yeah, I mean, after we got the ginormous presentation at the Sphere about the reimagination of the Wizard of Oz, the whole rest of the next few days in Vegas. So it's really about agents. Now, Google had released Agent Space towards the end of last year, but there were a number of key pieces that were coming in there that I think really made this the launch party. The other thing also, and this is where I kind of want to, what got me interested in your post, Vin, was that I've been kind of on this tear for a while about small is beautiful, that how long can this OpenAI party go on? And of course, Google was kind of a little guilty here too, in terms of announcing a 2 million token context window. But anyway, what I liked about your post is where you were talking about essentially that what's going to make agents work is much more compact pieces, much more compact models. So then could you basically kind of tell us, what were you really telling us there?
Yeah, I think it's about unit economics, right? Mm-hmm. If we're talking about large language models, everyone thinks, it's GPUs because of the training. Training is very, very compute intensive. That's the expensive part. But when you dig under the surface, you realize that training's really multiple phases, multiple components, but it's a one-time cost for the majority of these large language models. The recurring cost is the one that's really going to be as we're implementing agents and as we see more companies deploying agents. That's where the costs are going to come in. I've seen agents that cost several dollars per interaction or per conversation or to fulfill an intent. That's too much for the unit economics to work for most use cases. And so that's what I was trying to explain in the post, is that large language models are going in a different direction. Yes, at some point in the distant future, we will have the one model that can serve them all. But right now, large language models aren't reliable in what we care about when it comes to an agent, which is the workflow, which is delivering the outcome. And we have to do more work in order to make a big model that's also expensive, reliable enough to serve a specific use case like an agent's intended to. So it makes more sense, to your point about smaller is beautiful. Smaller is also cost effective. Smaller is also more reliable. I mean, define beauty. It is a whole lot of the things that align with the agentic paradigm and with the productization and commercialization paradigms. So if we want to see AI agents become products anytime soon, we're going to need to switch from this big model, one size, one model to rule them all, to much, much smaller models, higher reliability, lower cost to serve the intent, easier to maintain, more explainable. I mean, there's just so much more benefit to doing a small approach versus a big one.
In a way, this sort of reminds me of the old sort of maxim of fail fast. And I think what here we can say is fail small.
And maybe don't fail. With the smaller model, it's so much more accessible. And the capabilities that it takes to develop a smaller, I say smaller, I mean, we're still talking hundreds of millions of parameters at the very smallest. So we're still talking very large, but most companies have the capabilities to deploy that. Most companies have done something similar in the past and have that level of data accessible to them. Most companies are going to fail less often with a smaller model. So when you say fail fail fast with small, it's really also fail less often.
True, but the thing is, what I'm thinking here is that by going smaller, it reduces the risk of failure, and you can iterate and get to the fact that you become successful more consistently.
Yep. Yeah, you can build the capability so much faster. Yeah.
Yes.
Yeah, I think there's a lot to be said for fail cheap as well, because if you're only training a few 100 million parameters, your GPU costs are lower. Like you were saying, the amount of data that you need to consume to do that are lower. If your model goes off the rails and you have to start over, you're not talking this massive, like, I don't even know what the numbers are now to train an LLM, but they're outrageous, right?
Yeah, and it's also the amount of time it takes. To your point, failing fast. If you do a large language model, you might not figure out you failed until 6 months, 12 months down the road. That's when you really and the sunk cost makes a company do irrational stuff. They will stick with initiatives and they will stick with choices that don't make a whole lot of sense because they've already poured $2, $3, $4 million into it. So it's a whole lot harder to walk away from that than from a very small investment. The other great thing about small language models that I think everyone's trying to figure out, what's the minimum capability set? What is the minimum reasoning ability, reasoning obviously in air quotes. What's the smallest model that we can do from a pre-training standpoint that can be reused, and different sort of post-training, different prompt engineering, so that we can reuse that one small pre-trained model over and over again. And we don't have to do that pre-training every single time. We just do post-training, or potentially we take a post-trained model and use prompt engineering, use RAG, use any one of the, chain of thought, or any of the other types of approaches that you can use to teach a model on the fly, so that you're also reducing that first time cost as well. There's a whole lot of work being done to figure out kind of what's that minimum, I hate using intelligence, but minimum capability set.
Well, actually, I love the way you said that, the way you put that, because actually what was really interesting, at Google, at Next, where we're in the sphere, which is what we saw was both a big and a small problem when they were trying to reimagine the Wizard of Oz. And I'm not saying restore it, it's reimagining it, because basically it's when you're going to a screen that's 1,800 times the size of the largest IMAX in the world, you have to do more than just blow up an image. And part of it is that they want to do more, head to toe shots of, full on shots of Dorothy. And the fact is that in the original movie, there were exactly 8 frames that showed her red shoes. In other words, 8 frames that showed any part of that. And yet from that, they were able to train a model off of 8 frames of just less than a second of film or video to produce her red shoes. And that sort of invites some very interesting possibilities that we'll only gain through the learning curve, which is like, how small can we basically get to these these training data sets and models, and be good enough?
Yeah, how few shots are enough shots. Yeah, that's exactly it.
Exactly.
Yeah. Another thing I want to talk about is multimodal. And in fact, this actually relates to what you're talking about, Tony, because part of what they did is they combined these video generation techniques with traditional VFX and a number of other techniques to realize this. And in the domain of language models, I've talked to some companies that talk about they'll use multiple small language models for different tasks. So for example, analyzing medical records, they might have different specialist language models that do different parts of that. They'll use classical NLP for certain problems, and then they'll go back to LLMs for certain parts of that where the LLM is going to be a better generalist agent. How much of that are you seeing, this multimodal approach?
A lot. And not just multimodal, but I would kind of extend it out, so not just language, images, video, audio, not just constrained to that, but also bringing in more traditional predictive, prescriptive, diagnostic, descriptive models, access to data, apps. I mean, really going back through the technology stack and bringing more of these tools forward and saying, look, why would I reinvent this tool in a more expensive way? Why don't I just reuse this tool? And that's where sort of that MCP paradigm, and I know that there's competing standards, so I don't want to ruffle any feathers. I know we haven't picked a winner yet, but choosing one of those standards to allow all of these different models to interact. I mean, that is the future of this. You can't really think about this in terms of one model to rule them all, because again, we're back to that reliability constraints. And then further down the stack, it's a data problem. OpenAI doesn't have access to all of the data that it would need to train these very vertically deep and reliable models. They have enough data to do horizontal breadth, but that vertical depth to support use cases simply isn't there. And they don't have the data to change that yet. So we need to have a conversation about what do we do while the challenges of vertical depth really plague these large language models.
Yeah. I've also heard of a lot of human feedback type training for small language models, for example, where you can interact. Say, if it's a medical records use case, you can interact with a specialist in a certain disease, or if it's a business use case, maybe you interact with the product manager, part of the training, which you're never going to be able to do that with that kind of breadth where you're trying to train on every possible piece of data on the internet.
Now, you know what's interesting is over the past year, we've been hearing talk about trying to get to smaller models or to right-sizing models. And we started to hear about small language models. We started to hear about basically kind of ensemble approaches, which is kind of like what we're talking about here, and things like mixture of experts. What I'm wondering if agents are finally going to be the factor that really basically kicks smaller models into the mainstream.
I think it has to be, right? There's no alternative to it. And again, back to the data constraints. Different companies have different best-in-class data sources. They have access to different data generating processes. So the companies in the best position to deliver that vertical depth, well, it's not the same one, right? It's not the current large language model providers. It is across industries, across domains. So I couldn't agree more. I think the data really tells you everything you need to know about what direction we're going in, whether it's mixture of experts or really going old school ensembles and thinking about it in that way. But also thinking about the app ecosystems that some companies have built up over time, where they're only a couple of small models away from orchestrating a much simpler workflow, where instead of having to interact with all of these different apps and go into 5 different places to get data, you don't have to do that same context switching anymore. And they're only a few models or sometimes a couple of models away from being able to support their workflow in an entirely new way and transforming their product. So they have the lower barrier to entry.
Now, if I'm in product and I want to get started with some of these technologies, besides taking your course, like what's the starting point for this? Like, what if a company is interested in developing small language models, like where's their first stop to try to do something like that?
Well, there's tons of them that are already out there. And what's great about some of these open source models, you see Gemma, you see, I think Phi, Microsoft's got Phi. There's smaller versions of Llama, and Meta's published the A to Z from a technical standpoint. How do you do this? But no one's really figured out the product side of this. And I think that's that is the tougher part. And obviously I'm going to tell you take my course, but that's, again, rolling back to what you were saying, there's a lot of learning curve here, and there's cheap ways to learn and there's expensive ways to learn. And what you're seeing is a ton of companies right now are doing the expensive lessons and really paying a high price. So it's important. Experience matters here. Gray hairs help every once in a while, and this is one of those scenarios where gray hairs definitely help. If you've implemented machine learning models before, you're going to understand the productization a little bit better. But yeah, of course, I'm going to pitch my course. Buy my book, take the course.
Yeah.
Or the frustration will turn your hair gray.
Or yes,
the learning experience.
Yep, I have survived with less gray than most.
You've done just fine. So, this is fantastic. Thank you again for taking the time, and maybe we can reprise this conversation at some point later in the year, just depending on how things evolve. Because I think you're not wrong to say that things are going to be changing pretty fast, and there will be a lot of failure and some success for us to watch in the next couple of months.
Yeah, thanks for having me. Great conversation. Really appreciate it.
Hey, good talking, Ben.
Talk to you soon.